Next, machine learning algorithms that we're going to be covering are IsoForest and DBSCAN for anomaly detection. These algorithms, as rightly labeled, are for finding anomalies, and we'll go over kind of the business requirements that go along, or business requests that go along with what anomalies are and why that would be useful. But think of it, we're looking for outliers. So if you have a room full of people and somebody's exceptionally tall, like 7'5", these are ways that we can quickly identify them based on other data sets. So there's two methods for doing anomaly detection that we're going to cover. One is called IsoForest and one is DBSCAN. And again, on these the overviews of these algorithms, it's more important to understand how they're attacking the problem as opposed to just seeing what their results are, so you can able to differentiate between them and understand which use case might be better than others. So for IsoForest, we're randomly splitting features and values. And remember, when we're talking about features and values, features are data variables that go to predict a specific value. And so when we're separating the features and values, it's easier to find anomalous detections, kind of removing those dependencies. Anomalies are isolated in fewer splits, and so if you're making cuts across the data, it's very easy that an outlier will actually be noticed as an outlier in very few splits, as opposed to requiring more and more and more. It tends to say if you're going to split data up and we're not finding any outliers, that the data is very close clustered and it's getting difficult to find those anomalies, which may or may not exist. And so that's where it says normal points require many splits to isolate. Right. Outputs anomaly score. So giving an anomaly score, which is something that we use in the current work I'm doing, the closer to one it is, the more probability it is anomaly. And so you can use this as a weighted score, thinking at any uh, point in analysis, if we find data points or predictive anomalies with a very high score, it gives us a priority, right? If we're looking for risks or fraud, things with a high anomaly score will get more attention for individual review as opposed to something that has a lower anomaly score. It works well with high dimensional data across multiple data sources. It's fast, scalable to millions of rows because the action or the calculation is very, very simple, and it's best for transaction fraud or sensor failures because these things are high volume. Right? How many transactions go through a bank a day is hard to calculate. It could be tens of millions. And so we need something that's very quick at finding these fraud detections and indicating to users which ones need to be reviewed, right? So when we find something that's fraud in a bank, or if you have a bank account and you've gotten a fraud text, what they're doing is flagging an anomaly with a high anomaly score, right? And then they're sending you a message for review. And so there's part of it is the human review. You need to check to make sure that this is an issue. DBSCAN, or density-based spatial clustering of applications, this is an acronym, finds clusters of any shapes. So instead of just cutting away at major portions of the data and looking for outliers like IsoForest does, it's a forest, but it's still isolating outliers. This is more mapping out what the clusters look like and then finding the space between. Um, Points in sparse regions equal outliers, which is noise, right? We can find the clusters and identify their shapes, and then target what's left as as the kind of the anomalous group, right? If we're outside of the clusters, then we're going to be presumed to be anomalous. We want to get into the parameters because that's a little bit more into the data science and analytics portions. We just want to kind of know operationally how these work. It does not require any pre-specifying K. So remember, K clustering, we had to choose how many bins or how many categories we were going to choose, and that choice depends on how well the model does. DBSCAN does not require pre-specifying a K, so no user-defined number of class or categories is required. It naturally identifies outliers as noise points in the same way that we described earlier, and it's best for geographic anomalies and network intrusion. And so in this sense, instead of cutting away and finding outlier data points, we're looking at a very unbiased, or a very, I guess, grouped data set. So geographic anomalies, most big land masses are very close together. Again, it's very, very rare that they would be outside of it. But if we can understand the shape of continents, then it's easier to say, anything that's outside of this shape, outside of the boundary, could be considered an outlier. And so think of like, I don't know, Australia and then all the islands of New Zealand or something like that. So what business request is this answer, right? And so we had already kind of tipped our hand and said it's for anomaly detection, it's for fraud. And so let's look at these specifically and see which ones might be, which times, which algorithm might be better than the others. Which financial transactions are likely fraudulent? IsoForest scores each transaction, flags the top 1 to 5%. So this is, think of this as the we'll say the opposite of 1 to 5%, which is 95 to 99% certainty, right? And so that goes back to the anomaly score, right? The higher we get to 1, the closer it is an anomaly. So when we say top 1 to 5% for human review, we're actually saying with an anomaly score of 95 to 99%, and then apply that to the entire volume of what the data set is. And so we can't do more than this. Again, remember that if we're a bank and we have tens of millions of transactions a day and we flag 1 to 5%, I mean, that's hundreds of thousands or tens of thousands of purchases or transactions that need to be put up for human review. That's just not possible every day. So we have to keep it very limited based on human review resources. So it works when fraud labels are scarce. Are any of our manufacturing sensors reporting abnormal readings? DBSCAN identifies sensor readings in sparse density regions as anomalies. No label feature data needed. So when we do these sensors, we're checking for something and it's fairly consistent, right? Manufacturing processes or in monitoring processes, we're getting a lot of the same data. When we get outliers, it's very clearly outside of the boundaries of what's acceptable or thresholds or something like that. So this is very easy to find abnormal readings if you have a large historical database of what the normal responses look like. So again, setting that boundary, understanding the shape of, finding the shape of the data or what's acceptable, and then anything outside of that is anomalous. Which employee expense report should we audit? Again, this is a question of priority, right? We would like to audit everybody, and do a full review, but we can't do that. That's too expensive. That's too labor intensive. So we need to use data analytics to narrow down the scope to see what is at highest risk. Which expense reports do we see are most anomalous? And the underlying assumption there is that if it's anomalous, if it has a high anomaly score, then it's most likely carrying risk behavior and needs to be reviewed. IsoForest isolates unusually large, frequent, or oddly timed reimbursements from normal behavior patterns. So again, um, quickly identifying outliers, providing a risk score. The higher the risk score, the more higher priority it has for auditing. Are there unusual geographic clusters in our delivery network? So this is a question more to how do these clusters look? And now we're considering an entire cluster to be anomalous, right? So DBSCAN finds every delivery route clusters and flags isolated stops could indicate theft, rerouting, or data errors. And so even if it's a regular patterned behavior, it doesn't mean that it is not anomalous, right? So if I have a bunch of delivery drivers that are doing a specific route or roughly the same size route and roughly the same urban area, but one of them is taking 45 minutes longer and there's a stop that's way past the normal distance, we have some type of anomalous characteristic for that delivery route. It's not that having a delivery route is anomalous, right? It's a data cluster set, and so we can look at it by time or distance or acreage covered or other metrics that can cause it to look more anomalous. But it could also be done for things that's like maybe this delivery person is overworked. Maybe their route is too long, or we need to do a better job of resourcing our delivery people to loosen the load. So it's not necessarily always a gotcha moment. It can be a resource reprioritization effort. Last business request we're going to go over is which customer accounts show suspicious login patterns. IsoForest and login time, location, device features, flags accounts with anomalous access behavior for security review. So, I mean, lots of people access networks all the time. There's network traffic all the time. But if I see, a high network traffic at 3 a.m. or off hours time, it might be interesting to see what somebody is doing in the off hours of the third shift if that's not normal. If our usual user group is in the mornings and the afternoons, we kind of get that understanding of what the data cluster looks like. It's mostly high traffic in the morning. So if I have high traffic at another time of day, it's not that the high traffic is a concern. It's that combined with high traffic and the time of day now starts becoming suspicious. Data requirements for these anomaly detection methods for isolation forest um, and DBSCAN is works without labeled anomaly examples. Right? We don't know if they're anomalies or not. It's based on how the data is clustered. So it's kind of an evolution past the clustering methods of the k-means cluster. Handles high dimensional numeric data well. All right, these are finding anomalies for bank transactions or network access. These are very, very high volume number of instances that we need to review. It does that very quickly because it's a very direct and simplistic way of thinking on how to isolate noise or isolate anomalous points and give them that score. Effective even when anomalies are less than 1% of the data, which is usually the case. I would say most people are compliant. Most people are um, follow the rules and try to behave well within the rules that are established in systems. It's very uncommon, I guess, in human behavior to have anomalous behavior or risky behavior or try to circumvent the system. And so that's important. This is an important key because no matter how much a person is hidden in the masses, we can still identify using data analytics to see if they're engaging in risky behavior. And it's not necessarily on their part, but it's more just giving the leadership of a business actionable work, right? We want data supported anomaly detection so that we can create an action plan and address if it's appropriate. Requires fine tuning. So this is some data scientist or data engineering work, and so it's not super user friendly to work with this. But operationally, you should understand that these tools are available if you need to find anomalies. Results need business validation. And say that's a data requirement. That's more of a validation requirement. These models are not perfect, right? We're not saying that there's 100% accuracy and leaving serious decisions and action making to a model or an AI model or machine learning model. Obviously be very culturally sensitive today. So it's always important when you're making these analytics, it's that they get reviewed by subject matter experts, not just reviewed by you, but who does this work regularly? Who would be good at identifying an anomaly if they saw one? Those are called subject matter experts, and they always need to be consulted when using AI or machine learning methods. How do we evaluate? How do we know if uh, the models are doing well and how do we improve or what are our metrics for improvement? The precision at K, this is actually part of a confusion matrix. If you haven't heard about confusion matrix or matrices, it's a way to report finding false positive, false negatives, right? So those are two issues, type 1, type 2 errors that we need to identify. Sometimes some of those are very, very impactful. Like if we were to if we were to miss a cancer diagnostic, right, that would be very, very catastrophic. So that has much higher liability than accidentally diagnosing somebody with cancer because we can just run subsequent tests for confirmation, right? And so that's kind of the point. It's more in that case specifically. It's more important um, to prioritize not missing a diagnosis. So the types of error are important, and so precision K and recall and parts of the confusion matrix are good to discuss, but we'll cover that at a different lesson. Rock, we've talked about this. Over zero point 0.8 or 0.85 is a strong model. It's still 0.8. It says 0.85 here, but 0.8 is good. Anomaly score distribution. The visual check does the score distribution, so a clear separation between normal and outlier populations. So distributions, we have these bell curves, right? They look like this. We're looking for outliers. They should be well outside of the bell curve. Business triage rate, what percent of flagged items can the investigation team realistically review? So when you take these outputs, you also have to understand if you're going to audit them or if you're going to investigate them, what is your bandwidth in employee workload look like for investigation and audit? We can't audit every single person that pays taxes. Right? We don't have enough IRS agents to do that. We don't have enough time to do that. That would cost way too much money. And so we run through all of our returns, and some of them that are the most highest priority get audited. But you can't say that, I can review 10 million of these. It's usually several thousand that they can really do a deep dive and audit on. And so what percent of flagged items? Maybe it's only 0.01%.